Okay, we're looking at section 1-11. We're talking about the distance formula. And so I've given you the distance formula here. Some of you may have remembered that from algebra. It's the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if you have 2 points on a graph, say like this, you can plug these into the distance formula and it will tell you the distance between those 2 points. And for geometry, that would effectively be the length of the segment that connects these 2 points. Okay? Now, here's an alternate form of the distance formula that you may not be aware of. And that is the square root of, and this symbol is a Greek letter delta. It stands for change. So this alternate formula is the square root of the change in x squared plus the change in y squared. So really all of this part here, that's just the change in x. Take that number, square it. All of this part here is the change in y. However much the y changes by, take that number and square it. Now the reason why I'm showing you this is because a lot of people think that this one is a lot easier to work with than this one is. So right now, we're going to do this problem with the first formula, and then we're going to do the same problem with the new formula, and then you can choose whichever one you like the best. Okay? So if I were plugging into the original distance formula, it'd look like this. It'd be d equals, okay, so then we need a long square root sign here. And so x sub 2, that means the x coordinate of the second point. Here's the second point. Here's the x coordinate of the second point. Remember, in a coordinate, x comes first, y comes second. So that'd be negative 12 minus x sub 1, which is negative 9. So I've got negative 12 minus negative 9 squared plus, open, y sub 2, the y coordinate of the second point, 2, minus y sub 1, the y coordinate of the first point, 6, close, squared. So when we plug it in, that's what it looks like. We have a few steps now to simplify it down. And so negative 12 minus negative 9. Now remember, okay, you don't want, when you're combining like terms, you don't want 2 signs in front of the number. Just simplify it to 1 sign. Negative and negative make a positive. So that's really negative 12 plus 9, which is negative 3. So there's negative 3 squared plus, open another set, 2 minus 6 is negative 4. Close that, square it off. All right, so from here we're getting a little closer now. That would be the square root of negative 3 squared is positive 9, and negative 4 squared is positive 16. We can add those together now and get the square root of 25, and then we know the square root of 25 is equal to 5. So the distance between those 2 points would be 5. Now, let's take a look and do the same problem with the other formula and see how it differs. Okay? And so when I go to plug this in, it'll be d equals square root of. Now remember, this is change in x. So look at the x numbers and let's see if we can tell how much x changes by, how much it changes by. So from negative 9 to negative 12, okay, that's going down by 3. And so really it's just changing by 3. So I'm going to write the change as 3. Now even though it's going down, yes, that should be negative, but here's the great thing about this formula. Okay, this is going to be squared anyway, right? And negative times a negative always makes a positive. So really in this one, because of this formula with this change being squared, even if it's going down, you still don't have to write negative. So negative 9 to negative 12 is a change of 3. It changed by 3. So that's 3 squared plus, all right, change in y. Y goes from 6 to 2. It's going down by 4. But it's really, we just write it as a change. What's the change? It changed by 4. So that'd be 4 squared. Okay, so the change in x is 3. The change in y is 4. I just plug those 2 numbers in there and square it. Okay, now, let's take a look at this for just a minute. Okay, with this just one step, we're really like all the way down almost to here in the other one. And we'll be there on the next step. If I square this stuff out, 3 squared is 9 plus 4 squared is 16. All right, so I'm already down to this step. And d equals to square root of 25, and then so d is equal to 5. So we get the same answer, but it is a lot simpler. Okay? So if you can look at these two numbers and tell what the change is, and just write that number in for the change in x and the change in y, that'll be much simpler for you to do the distance formula than trying to have to deal with -12 minus -9 and all this kind of stuff. All right? So you can use whichever one you want. I've had students that say, I like this one better because that's how I learned it in Algebra 1. And I've had students that say, I like this one better because it's shorter. So you got your choice. Choose either one you want. When I do the practice problems, I'll probably use the shorter formula. All right, so again, we want to find the distance. Here's the next problem. So it's going to be d equals the square root of. All right, so again, I need the change in x. From 3 to -2, that's down by 5. So we'll just write 5, remember? Even though it's down, you don't have to write negative because it squares itself out, plus. From the change in y from 15 to 3 is a change of 12. It's down by 12. And by the way, if you want a shortcut to get the change, if the signs are the same, subtract the numbers. If the signs are different, add the numbers. So here the signs are different. 3 plus 2 makes 5. Here the signs are the same. So 15 minus 3 is 12. So that's a shortcut to get the change. If the signs are the same, subtract the numbers. If the signs are different, add the numbers. So now back to this. We've got the distance is equal to 25 plus 144 as I square those two numbers. And then the distance is equal to, that would be 169. And now I will take the square root of 169, which is 13. So the distance between these 2 points is going to be 13. Okay? Now, it's not always going to be a whole number answer. Okay? And I'm going to show you how to deal with one where it's not just a whole number. So like on this one, the distance is equal to the square root of, from 3 to 7, that's a change of 4, plus the change in y from 5 to 9 is also a change of 4. And so that would be the square root of 16 plus 16. And that's going to be the square root of 32. Now, square root of 32 doesn't come out even. If you put that into a calculator, you would get 5.66. Now, here's the issue. Okay? If this was a multiple choice question, your answers may not be in decimal form. All right? So they may be in square root form or radical form. All right? So what I'm getting at is, what if your answers were this? 2 square roots of 2, 3 square roots of 2, 4 square roots of 2, and 5 square roots of 2. So if those are your answer choices, how would you know which one is the right answer? All right? There are 2 ways to do it. You could just put these one at a time in your calculator and then see which one equals to 5.66. However, if it's a free response and you don't have answer choices and it says write it in radical form or give the exact answer, we may run into trouble with that. So here's how you would simplify it by hand. First of all, you want to break this number 32 down into its prime factors. So it would break down into 8 times 4, but that can still break down even more. 4 times 2, and 4 is 2 times 2. And then one more 4 would be 2 times 2. So really underneath the square root, what you would have is 2 times 2 times 2 times 2 times 2. So all of that is now under the square root. Okay? Now, how do we continue to simplify it? And by the way, 2 times 2 times 2 times 2 times 2 is 32. So we broke 32 down to its prime factors. Now here's the deal. Underneath the square root, you can take pairs of the same number outside of the square root. Because 2 times 2 is 4, but the square root of 4 is 2. So 2 2's underneath the square root come out as 1 2 outside of the square root. So there's a pair of 2's here I can pull out, a pair of 2's here I can pull out. So outside it would be 2 times 2, but what's still trapped underneath that doesn't have a pair? This 2. And then 2 times 2 on the outside is 4, and then 4 square root of 2, you know now is your correct answer. All right? So like I say, if you have a multiple choice, you can plug these one at a time and see which one gives you 5.66. Or if you want to simplify it by hand, break this number down to prime factors and then pull out pairs of numbers. Okay. One more example. Let's do one like this. Let's say the distance, or I want to find the distance between these 2 points. So I need the change in x, -5 to 1. That's a change of 6 from -5 to 1. Remember what we said, if the signs are different, you can just add the numbers. 5 plus 1 makes 6. Plus, from 3 to 5, that's a change of 2. All right, so we're just writing the change in there. Then that's 36 plus 4, so the distance is equal to the square root of 40. Okay? As a decimal, that is 6.32. You could figure that out pretty quickly by plugging that into the calculator. But once again, what if these are my answer choices? 2 square roots of 2, 2 square roots of 3, 2 square roots of 5, and 2 square roots of 10. Well, how am I going to know which one is the right answer? You can plug these into the calculator, see which one gives you this. Or we can do it by hand. Let's break down 40. So 40 is 10 times 4. And so 4 breaks down to 2 times 2, right? And 10 breaks down to 5 times 2. So that's 5 times 2 times 2 times 2. All right, so that's my prime factors. Now, I'm looking for pair of numbers. There is a pair of 2. And so 2 will come out. Now 5 and 2 don't have any pairs. There's no 5 to make a pair. There's no other 2 to make a pair. So that'll just stay underneath, and 5 times 2 will multiply back to 10. So there's your answer right there, 10 square roots of 2. All right, so this is probably the form that your multiple choice on your quiz is going to be in, by the way. All right, so with that, we'll leave you to it, and we will be back with the next lesson very soon.